Hey guys, uh, this is part 3. This is part 3, and yesterday I left at problem number 12, so we will continue from problem 12. So yeah, let's get it started. So as you can see, we left here only with the diagrams. So in the problem number 12. Also, for right now, we can just write the equation for the torque and the acceleration for the mass as well as the pulley. It's not pulley, yes, it's in the shape of pulley, but it is a hollow cylinder. So, firstly, write the equation for the Newton's second law for the block. So, for that, as you know, block is moving towards downward. So, it will be like mg minus t is equals to mass into acceleration, like that. So, actually, we can write mg minus t is equals to mass into acceleration, not t minus mg, as we already know block will move towards downward, not upward. So, yeah, it's correct. And one more thing, okay, as you already know that string is not slipping, that means torque is equals to alpha, and also acceleration is equals to mass times, sorry मैं क्या बोल रहा हूँ, acceleration will be the r alpha. Yes, that's right. So for right now we can just write equations and then we can solve manually, right? So this can be the equation number 1. I think equation, let's see what I think I had let's run this first. No, it's not running any equation. Actually I made a command called eqn, I think. No, there is no eqn command, but actually we can make this command. Let's remove this part, maybe that will work. No, still it's not working. Let's see what I can do. H fill and then let's write 1. This may work. No, it's not working. So I wanted to name this equation 1 2 3. Yes, I know I can use unstart version of align. This will number the equation, but I don't want each and every step to be 1 2 3 4 like that. So for right now just we will deal without equation number. So this is for the cylinder, not the second law apply, torque equation बोल सकते हो. Apply torque equation for the cylinder. Yes, this will be much better. And on the cylinder tau torque which is I alpha, and now we can put torque as tension and cylinder to be mr square, not because cylinder is hollow, so that's why it will be mr square, which is equivalent to the ring. So yeah, let's run it first, then see what we can do further. And as you know, we have to find the acceleration of the cylinder. So tr is like that, and then we can calculate simply tension, because r will get cancelled out, and this will initiate the part. And one more thing here we have to do is alpha part, substitute not substitute, for no slipping. What's the condition for no slipping? Condition for no slipping is a is equals to r alpha. Yes, that's correct. Now we can substitute the value of a, the block. Yes, it's perfectly right, and we can proceed. Why we need substitute the value of a and t. No, we have to put we have to substitute the value of alpha and a. From there we can find alpha actually. Then it will understand diffraction A by R. Yes, and then alpha and t in the equation, and this will I think provide the proper suggestion. Yes, this should provide yes, this is the best. And then we can put alpha g by 2. Yes, it's right. As you can see, firstly we applied the Newton's second law, and then we applied the torque equation, then condition for no slipping, and then just substitute the value of alpha and t in the equation of the block. Because the block is mg minus t is equals to ma, so we just put it the value of tension, and then after alpha, I think we should explain one more line. This will get intimidated by few other. So mr and alpha is this will say, let's ma is equals to ma. Yes, yes, this is much better. And then expression is g by 2, which is the kinetic extension. I think we can solve in few lines actually, if we think something different. For no sleeping, no, I don't know what should I do for no. This is the only bit for right now. Yes, let's move on to the next one. And this is kind of the easiest problem of this paper. Yes, right arrow. In this problem, there is a rod pivoted at one end and lifted up to 30 degree, or you can say rod is rotated to 30 degree, and then after just left, and it will just starts rotating along the pivoted point, and we have to find the angular velocity when it passes at 0 degrees, or you can say when it becomes completely horizontal. At that point we have to find the omega. So as you know, note is like no loss of energy is happening at the pivot point, so we can just conserve the energy, or you can say we can apply the conservation of mechanical energy. So rod is rotating, that means kinetic will get converted into rotational kinetic energy. That's it. So let's run it first. I think copilot is good here. Apply the equation of conservation of energy, mgh, which is half I omega is here. That's absolutely correct. I is equals to 1 by 3 ml square by 3 because it's rod, and I think it just eliminated everything and solved directly. Yeah, not wrong, but steps are missing. Doesn't matter, it's okay. Let's accept it for right now. Under 30, yeah, it's correct. So let's move on to question number I think 14. Yes, 14 is interesting. Not interesting, same boring questions. Okay, right arrow, and begin with the alignment, and I think we have to draw some diagram for this one, but if we can apply the instantaneous axis of rotation, then we can solve it quite easily. I think so. Yes, let's read the question first. So this is a hollow cylinder, and at the top of the cylinder there is a force of 40 Newton which is acting towards right, and everything is provided mass of the cylinder as well as the radius of the cylinder, and this 40 Newton is pulling towards right, so that cylinder is rolling without slipping. That means it's in pure rotation motion, right? And then find the angular acceleration of the cylinder. So I think this can be solved in few lines only, and this will be great. Let's firstly accept the equation for copilot. So as you can see, yes, it's applied very. One second. Actually, we got the correct answer, but I don't think it's right. Yeah, it's right. but no, it's not right. uh, like, how can you say friction is not acting? No, it got the answer, but I don't think it's right. So let's start from the beginning. uh, we can assume instantaneous axis of rotation, which is at the contact point, and about the instantaneous axis of rotation, it is in the pure rotation motion. So for that we can apply torque is equals to alpha. Torque will be 40 times the diameter, and moment of inertia about the contact point will be like mr square, which is about the center of mass. Then we can shift according to parallax theorem, which is again mr square. So 2 mr square will be the moment of inertia, and here it is using half as, which is totally wrong. So again, uh, let's apply the equation for torque uh, about point of contact, and then we can which is 40 Newton, yeah, F C dot, yes, 2R, yes, we dot 2R, which is diameter, is equals to I alpha, yes, and then we can proceed. What happens if hollow cylinder over the axis? No, we want alpha. To F R by I, yes, right. No, man, they already know. Let's put this first. I, which is wrong. Simply it will be 2. Oh man, let's delete all these. I think this is the crap. Alpha. Oh, okay, why are you giving that information? Let's put firstly defrag. Yes, it will be 2 FR, and then we can put a moment of inertia, which is 2 m r square. So yeah, that's the correct answer. And then F by mr, yes, it's correct. Then we can put, yes, F is 40 and 5 dot mr, yes, that's right. Which is 80 by 16, yes. So alpha is 16 radian per second square. Yeah, it's correct option. Apply the equation for torque about the point of contact, and we can describe here a little bit as in pure rotation motion. Assuming instantaneous axis of rotation, rotation is a point of contact about which roll also the cylinder is in pure rolling motion, pure rotational motion. Pure rotation is at the point of contact about which cylinder is in pure rotation motion. क्योंकि पॉइंट ऑफ कांटेक्ट पे अगर स्लिपिंग नहीं हो रहा, that means we have to describe about the slipping as well. As one second, as cylinder is rolling without slipping, without slipping, that means it is in pure it is in pure rolling, in pure rotational motion about the point of contact. Point of contact, and then apply the equation for torque over the point of. I think this is much better solution. As the cylinder is rolling without slipping, that means it is in pure resistance motion, and about the point, not and about the point of contact. So we can apply the torque equation. Yes, it's right. Let's move on to question number 14. Question number 14. I don't know how to solve 14 actually. Let's try. Begin a line. In 14. This was 14. Let's go to 15. So 15, as you can see, is a system in which a rod, is pivoted at its center of mass, and there are two individual springs which is connected from both the ends of equal spring constants. Let's zoom it a little bit. Yes, equal spring constant, and we have to find the oscillation of this system, because whenever we just disturb this system, or you can say we just rotate it with a small angle clockwise or anti-clockwise, then after leaving it will start oscillating, and we have to find the frequency of the oscillation due to the both the spring, because it's a system, it will not work in isolation. So what we can do, let's firstly draw a diagram in which rod is slightly rotated, and then we can find out the torque. I think without diagram we can do it or not, I don't know. We should. I'll draw it first. So where is the solution? Yes. Let's draw some diagram. It will give us some perspective in a better way. So begin center, begin text picture. Yes. Let's see how many viewers are there. One. Okay, don't worry. I'm just making this solution. Maybe in the future some of you will watch it. Not for the purpose of physics, but the purpose of latex maybe, or maybe physics. I don't know, because I'm not explaining physics very much, as you can see. Just I'm focusing on the latex part or co-pilot thing. So yeah, let's copy this code and just paste. So let's run it first, see what is happening here. So there is nothing special, as you can see. We just render the same code. Now we have to rotate this rod, and about the point O, which is at the origin. So rotation is uh, easier here. So let's rotate in clockwise. Let's rotate with 15 degree. So as you can see, rod is rotated, but everything is not connected, so it got like detached. So we can connect her. I think 10 degree is more. Let's do it. Sorry, let's do it for 10 degree. 15 was much more. And now we can connect this segment from this rod. I think diagram is not uh, drawn perfectly with much thinking. So let's think what we can do here. So we want to connect this snake part. A snake is a kind of a spring here. So this snake part, we are gonna join this to the rod end. So what if we replace this rectangle thing with a node? Then after we can I don't know what to do here. Can we name it? No, naming is not enough. For right now, just move it for right now. That will do the job, I think. 2.15, I think. 2.15, not 25. Will do the job maybe. From where it was initially connected, yes. So I think that's okay. And minus 2.5, 2.25. This will do the job for right now. But in the future we have to be careful. We can just change the angle and everything will settle down accordingly. So that is how a diagram should be made. Actually I made this diagram but without much of thinking. So let's move on to the solution part. Let's zoom in a little bit and see is there any physical contact or not. So as you can see, there is no physical contact. We can change slightly. Let's say 30 and see what happens. Yeah, it made the physical contact. Yeah, it's good, I think. So as you can see, both the spring now get into the physics part. So as you can see, if we rotate this rod by the theta, then both the spring will get elongated and will start pulling towards itself, so that the rod will get a net torque in the direction of clockwise. And whenever we 1 second. So yes, this rod will get a net torque towards clockwise, and then after leaving due to the momentum, it will cross the midpoint and it will starts rotating in the entire clockwise, because it has the momentum and you cannot just zero the momentum instantaneously. So because of the initial rotation, it will get the momentum, and this momentum will continue to do the job, and spring will continue to do the job as well, but spring will just oppose the motion. So if we rotate this rod towards clockwise, then compression will happen in the spring, and the spring will try to apply the torque in the anti-clockwise, so that it will get into equilibrium. So rod will like this continue happen until infinity time. So let's move on to equation part. So what is the length of this rod? I don't know. Yes, to lightest information of length. Yes, length is heavy, mass is m. So let's write the equation of torque. Enter text. The equation of torque is about point of contact, not about the point of about point O बोल सकते हो, that will be better. Yes, so torque is equals to I alpha. I alpha. That is interesting. Why we should write torque? I don't think we should use I alpha. Should I? No. For I may just calculate the torque. No I alpha, just torque. So firstly, torque is force into perpendicular distance, right? So force will be k times x, k times x, or into k into c dot कर देता हूँ, c dot times x times sine of theta. No, L by 2. No, idiot. L by 2 into what can I say, sine of theta. Yes, sine of theta. Sine of theta. Let's remove all this part. We can just double or copy anything, but firstly run this part. So as you can see, apply the equation for the torque, and torque is equals to k times x, no, not x, because we just added c dot L by 2, so there is no need for x. X is the elongation. Or should I? I think we should just copy. Let's put another line. I think that will make sense. No. What should I do? We should just, I don't know. Come on. Let's put another line, that will be better idea. K times x. K times x plus k times x मैं करता हूँ, and then we can add into text, where into text x is equals to dfrac L by 2 sine theta. Sine theta. X is the elongation of the of its spring. Yes, that is much better. So we can just put it twice, and we can remove this part. And one more thing I think we have to do is the elongation of its business. Let's into text again we have to add, because theta is small, as theta is a small, theta. That means yes, torque uh, torque is I alpha. Just scale theta. Or we can say restoring torque. The equation for restoring torque. Restoring torque. So we can apply minus. In the whole drama we can apply minus, so that it will look correct. Actually it's already correct, but for some person, yeah, they will object like, whoa, we need to. So for that I'm putting minus, otherwise it's okay. So defrag mode of inertia of this road about the point O is ml square by 12. So ml square by 12 alpha beta, yes, it's right. Alpha is yes, alpha is, I don't know why alpha is 12. Here L will get cancelled out, then omega square times theta, then yes, 2 pi upon omega will do the job. But I don't think 12 is the right. I think 6. I made this problem, and at that time I solved and it came out I think 6, not 12. So something must be wrong. Something must be wrong. I think I made a mistake somewhere. I don't remember exactly. Is it correct? Because from this point of view, it seems correct, but I don't know is it correct or not. ml square upon 12, yeah, it's right. K, no, there is no K value. By omega upon 12, here omega is a square root of 12 K, it's wrong, man. After, even if we cancel out the L part, we will have still have the 12. That is wrong. I think I missed somewhere. Either solution is wrong or I don't know. Let's see. I think I copied this problem from J main. I don't mean exactly. Let's see. Some J paper, J main, I think, and it's probably 2019 because 19 has the best questions in terms of logics and calculation, physics wise I'm talking about. So this is not, somewhere I saw this problem, I don't know where, but yeah, I saw. No, there is no physics, no idea where I saw. Let's yes. I think no, yes, this is 2019, and from where I got, I have no idea how 19. Let's check out a book. Where is book? 19, where is 19? Yes, this is let's search for SHM. Where is SHM? Acceleration wave, yes. So let's check it. Somewhere it has to be. Yes, this is the problem. As you can see, 6 is the right answer, but I don't know how it got incorrect. Ly2 cos, no, it must be sine. So yes, it's correct. KL square upon theta. Wow, how it happened? 1/12. Oh, no, it's right, man. Solution must be wrong. Solution must be wrong. Because yes, for those small acceleration, torque is like KL. How it's KL/2 times for a smaller theta. Yes, I know it's theta, but Ly2 cos theta. No, it's not that logic. Why can't I do like Ly2 sin theta and then Ly2 theta? That would be much better. Oh, that is the problem. We didn't add the perpendicular distance. Oh man. No, that is the problem. Yes, fundamentally it's wrong. We only applied the force, but in reality it should be force into perpendicular distance. So yeah, we should add c dot, and then we can add dfrac Ly2 actually, because yes, we can see Ly2. We should add ideally cos theta. Let's add cos theta as well, no problem. Cos theta, and again here the same, we can just copy this c dot part and the whole thing. Yes, we were doing it wrong. So now it's correct. I think x is, yes, everything is fine. 2kx, then we can put cos theta, and we can remove cos theta because cos theta will be 1, because and cos theta is the elongation, and sin theta, no, still leave it. Cos theta, leave it. In this part, as a decimal is equals to theta, and we can add quad, and then we can say cos of theta approximately approx 1. This is the correct way. Yes. So yeah, cos theta tends to 1, and I think torque is I alpha, then we just multiply, and it will remain L square by 2. Yes, so we have to change a lot. Let's say dfrac L square by 2. This is the correct part. Yes, and from now on we should continue L square by 2 part. Command C, command V. We should remove this part. I think X. Yes. So yeah, as you can see, it's right now. Now we can cancel out the L part. I'll just remove this line. It will prompt automatically. So now we can alpha is 6 by, yes, theta, and b. Let's run it first. Maybe it is still wrong. I don't know. So yes, theta, that means omega square. That means omega square is equals to 6 by, and frequency frequency is equals to 1 by 2 pi square root of s. I should solve omega actually firstly. Omega is equals to square, yes, it will complete. So yeah, one more thing here, we have to justify with apply the equation for the period of a compare with the equation. Yeah, that will be better. Compare with we can put this equation which is alpha is equals to minus omega square times theta. Yes, this is much better. Now compare with the equation of SCM, alpha is equals to 1. So yes, this is a better solution. Oh man, we got straight into question number 15, and let's move on to question number 16. I think 16 is pretty easy, we know it to solve, but anyway, we have to solve. Push, is it live? Yes, it's live still. 41 hours. So let's solve this one. Firstly, we can just simplify this equation. As you can see, this is the equation of a wave, or you can say SCM, because both the equations look similar or exactly same. So because fundamental of sound or wave is the vibration, and vibration is SCM, right? So that means mechanically it will look same equation by but the phenomena occurs differently slightly. So we can say that wave is the vibration is the cause of wave. That is, I think, the best way to describe. So let's move on to this equation. So firstly we have to simplify it in the shortest form. So we have intertext. I think we should describe something before solution. So let's simplify this equation. Yes, topological identity is correct. So y is equals to let's run it first, how it looks. So yeah, as you can see, it does nothing except just put it accordingly, and we can do something. Yes, I don't know why Copilot is getting so better and better. But I think this time it messed thing up. No, that is not the correct solution. Let's do it manually. 5 left, right, yes. So we have to multiply as well as divide by 2. So we can this is much more tedious, like describing everything we are doing. Multiply and divide by 2, and so this will become 10, and this will become, let's say diffract. Why diffract is not added in the command? I don't understand. Frac is added, but frac is much smaller, so I don't think that is suitable for our situation. Let's 3 pi t, 3 pi t, and then after because we divided t frac square root of 3 by 2, because initially it were only square root of 3, and then we can put cos of 3 pi t, 3 pi t. So yeah, some may ask why, because we wanna condense both these term into single, so we can apply sin a into cos b plus cos a into sin b, so that will condense into single trigonometrical function. So let's continue with that, and we can say 10 times left, and half we can use as the cos of pi by 3, that means ki cos we can use left right pi by 3 and into sine of 3 pi t into sine of 3 pi t, and again we can use cos sine instead of cos. So just we have to I think copy this whole part, and we can just replace this with sine. No visual insert mode, yes, sine part, and then also this is the cos part, yes. Let's run it first and see what happens. So yeah, as you can see, we now expanded completely, so this will be cos a into sin b plus sin a into cos b, and this will convert to I think it's right. Yes, it's right. Let's run it first. Sin of a plus b, and we should apply the equation for amplitude, for time period. We can say compare the amplitude is tensor, and time period is 2 pi by omega. So tensor time period is 2 pi by omega. Let's put it amplitude A and time period 2 pi by omega. Let's put it in the fraction. I think no, I think it's wrong, man. Let's add one more and it will solve the problem, I think. Yes, compare. Oh yes, it provides weight, and yes. Now we should not write this part and it's over. So yeah, as you can see, now it's finished and it looks quite good. So 16 is done. I think I don't need to explain the physics part, you know already. We are more focusing on the latex part here. So yeah, this is done. I think we are reaching 1 hour mark. Oh man, too much question. Still I'm in 16, we need to do 17, 18, 19, too much. So let's move on to question number 17. 17. What is 17? A particle is with simple harmonic motion with an amplitude of 5 centimeter. When particle is at 4 centimeter from the mean position, the magnitude of its velocity in SI unit is equal to that of its acceleration. Then the time period is oh, I think it's too big, but I don't know, is it correct? Let's continue with the suggestion first, then we can see. Velocity is no, as a particular first node from the main position. Itna magnitude of velocity, which is omega square, not omega square. Let's complete with line by line. At this position, at this position. That means omega square x yes is equals to 1 second. No, oh man. No, from this point we can find something else. I think cos theta. Yes, for that means yes, 4 5, yes, right, that means we need, I think, cos of something. Yes, so right arrow, cos of, yes, just 3 5. Whoa. PM, what is PM? Let's run it first, then see what is PM. I think it has to be left with the so yeah, as you can see, we have the equation for the SMA is sin omega t plus 5, and according to this problem, when the particle is 4, that means 4 is equals to 5 sin omega t. That means we have the sine value, we have the cos value, not plus minus. We have we are just thinking in terms of magnitude, right? So right now, mean position, so it's 3 by 5, and the magnitude of the velocity, we are thinking, because time period not negative at this position, that means velocity, yes, velocity is equal to omega a cos omega t. Yes, we can say omega. Let's run it first. Yes, omega a, yes, then acceleration, no, acceleration is equals to minus omega square, yes, cos. So yeah, we can find well, this is right, PM plus minus. Now see, acceleration, no, acceleration is equals to acceleration is equals to magnitude of acceleration is equals to magnitude of velocity, yes, That means t is equals to omega. Yes, let's run it first. So yes, we can now put the value of everything. Let's run it first. So yes, omega square 4 by 5 3 by 5 not plus minus, idiot. We got its magnitude only, so no plus minus, so we thought is enough. So omega, and now time period. Wow, it is awesome. 8 pi by 3, yes. If I from mean position, that means we don't know. Yes, so for that we can use this idea as plus minus will be better idea, plus minus 4, yes. So we can say plus minus, yes, that's right. Then we can say yes, plus minus, and because we have this part, that means we can now use this modulus part, and that will set the tone, and then we can yes, no, it's good, I think, because we have applied the modulus part. Yes, 8 pi by 3. Yes, it's good. So yeah, 17 is done, as you can see. Nothing special here is applied. So let's move on to 18. So in 18, oh, it's quite simple. Energy is constant in SCM, so total energy does not depend on its position. Energy does not depend on position. Let's continue with the energy. Or should I don't know. For sure. No. Should I? Let's equation x is equals to a sin omega t plus phi, right? So kinetic energy. No, half mv square. We can v is equals to, and then we can that's why line break is too large, so we can just remove this line break. Okay, where were we? So half m v square plus half kx square. Yes, so let's run it first, see what it renders. Yes, so as you can see, now we can say energy. I don't know. Let's see. No, this is not the right part. I think B should equalize with force is equals to kx, and then we can no idea. What should I do? Let's do it at force F force minus kx. So force is equals to no. Actually, this should remove from here, and then after we can apply expression is equals to yes ओमेगा इसको साइंस करें एंड मास से मल्टीप्लाई कर दो दोनों साइड, तो एम ए इज इक्वल्स टू नो माइनस ओमेगा ओमेगा स्क्वायर 5, then एम ए को we can write force kx minus kx, and then write yes, then k is equals to we can write yes. So this is the right part. Yes, as we know we solved it, omega square is equals to k by m, and then we can replace this whole energy thing with the help of yes. As we run this part we will get the idea. Yes, omega square k square, then we can prove energy साइंस को प्लस कस करो yes, and we can say energy is constant. So now into text, as you can see independent of x. Yes, this is the right. So yeah, option 4 will be the correct one, independent of x. Total energy does not depend on the displacement of the particle in SCM. And let's move on to second, but I think we have to clarify here something, because we just directly applied minus kx, which is a bit random, I think. I don't know. Let's continue with that. What is the point of paper? You do not have to explain everything in the paper, just you explain the logic, right? So yeah, let's continue with the next question, which is 90. A particle is executing SCM, and at the mean position another mass m is attached to it, and then we have to find the ratio of their amplitude before and after. That means we have to find A1 is to A2. Yes, let's complete the suggestion. I think Cobalt suggestion is getting pretty good. I don't think here it's good actually. Should I accept this suggestion or not? Or should I actually manually? No, I don't know. I'm thinking of taking a break. Let me explain this problem. Actually, you can do by yourself if you are interested. So when the particle will be at the mean position, then at that moment we just gently placed a small mass m, और उससे होगा ये कि सिस्टम का एक्चुअली मोमेंटम चेंज नहीं होगा क्योंकि सिस्टम पे कोई एक्स्ट्रा फोर्स नहीं आ रहा. अगर हम लोग पार्टिकल को इट्स लाइक इम्पल्सिवली प्रोजेक्ट कर रहे हैं तो यह सिस्टम का इम्पल्स चेंज होगा, दैट मीन्स मोमेंटम चेंज होगा. बट एक्चुअली में सिस्टम के पास कोई इम्पल्स नहीं आ रहा है उस मास को प्लेसमेंट करने से. दैट मीन्स उस मास को हम लोग जेंटली प्लेस किए. दैट मीन्स कि वी कैन कंजर्व द लीनियर मोमेंटम ऑफ द सिस्टम. सो सबसे आसान ये होगा कि हम लोग मीन पोजीशन पे लीनियर मोमेंटम कंजर्व कर देंगे बिफोर एंड आफ्टर, and in that way we can just let's solve this, right? और सोल्व करना बहुत मुझे टीडियस लग रहा है. एनर्जी नो एनर्जी का इक्वेशन का जरूरत नहीं पड़ेगा आई थिंक, उससे भी सिंपल हो जाएगा. मोमेंटम कंजर्व करना है एंड देन मोमेंटम कंजर्व करने के बाद क्या करूँगा मैं, A1:A2 यस ओमेगा आ जाएगा. बट ओमेगा 1 ओमेगा 2 का रेशियो एक्चुअली में कैलकुलेट करना पड़ेगा. क्वाइट टफ. रेशियो कैसे कैलकुलेट करना, नहीं रेशियो. Yeah, I think in previous question we already solved about the omega, right? So yes, we can use that equation. Yes, where it is? What is the purpose of that omega? I don't know where that came from. It yes. As you can see in the previous question, we have the omega square is equal to k by m, and we can use this application, use this equation in this part actually. So let's continue. So intertext. We can one second. Yes, we can apply. No, like conservation of linear momentum as a spring. Linear momentum at the mean position, at the mean position, because this small mass, small m, is placed gently, and this won't cause any change in cause any impulse, hence the momentum. Hence no change in the momentum. So yes, this is correct I think. mv1 plus mv2, yes that's right. And then no mv1 and v1 is omega 1 a1, right? And a1, yes right. Wow, no I think we have to add one more thing in the text. We have another equations, another set of equations for SCM, which is omega 1 cos square is equals to k by m, yes m. Come on, this. As you can see, it's right. One more thing I have to do. We can arrange this part here. No, this is not giving the proper suggestion. I think we have to put man only, that will be better. Yes, m times yes, this is right. Let's continue with this one. So yeah, m times k by m cos square a1 m times, yes, and then we can proceed a1 by the square root of yes. Ratio of a1 a2. So yes, this is the correct solution. We just applied the conjugation linear momentum, and then we just put it the value of omega, and this is how we solve this out. So let's move on to another question, which is 20. I think this is the last problem from optional one, or we can say objective question. I don't know where I'm betting this, but in this question we don't need anything, any equations. We just have to think logically. So as you can see, momentum versus height plots are given as the option ABCD, and we have to choose the correct option. So the suggestion is a particle is thrown upward in the gravity, against the gravity, and we have to find the momentum versus h. So yes, it applied, I think, quite. Let's continue with the suggestion first. mgh is the conservation of energy, yes. V is itna, P is mb, that means key. We can find, yes, it's right. As you can see, momentum is increasing with height, but at the same time it will it will, no, I don't know what should I do. It gives as the square root. जब ये ऊपर जाएगा तो इसका मोमेंटम पॉजिटिव होगा, बट एज ए फंक्शन ऑफ एच लाइक स्क्वायर फंक्शन, सो mgh is equals to half mv square, and no, this equation is wrong actually, because it found the initial momentum. Actually we don't want that. We want as a function of no, we want the relation between velocity and the height. This is not the relation between velocity and height, or is it? Yes, it's the relation between v. I don't know. Let's apply the equation, basic equation of motion. That will be much simpler. Apply the equation of motion for the ball, which is bs square is equals to u square plus 2gh. And g should be negative, yes. So minus 2h, because g is negative. Yes, that is correct. And we can find, no, how it's 0, idiot. Yes, So equation of momentum is like this: P is equals to m times the squared, and then we can put yes h is 0, then momentum is max, then you can say it's satisfying the momentum part, and then again it will reach the maximum at momentum will be 0, and then after whenever it starts to get down, it will start the negative momentum, and we should use plus minus. Velocity will be positive and velocity will be negative. It depends on which part. I don't know. I want to describe a single equation for both, but let's use plus minus. That will be better. Plus minus, yes. Plus minus, yes, and then plus minus, yes. So yes, plus minus. So momentum while going, like let's add one more sentence. While going upward, let's move on to let's move on to next, or we should leave it here or take a break. Let's see, it's 1 hour and 23. So right now I'm gonna stop, and in the next part I will do from 21 to 29 or 30. Yes, it's 30. So let's take a break, and hopefully we can join either tomorrow or at the midnight probably. So yeah, thank you for joining me, and see you later.